Hello, hello,
Hello.
hello. Hi.
Hi, can you hear me?
Yep, I can hear you. Hello. Hello?
Yeah, I'm sharing the
Hello.
screen now.
Yeah.
So when you open the MATLAB, you'll get this window. First,
Sorry, could we open up the question sheet first?
can you see it?
Yep.
So first, I'm opening the MATLAB. In that MATLAB Simulink, if you click, you will get a blank model. Click on blank model. So in this blank model, according to the question, so there is a voltage source which is connecting the transmission line, then a node. So the transmission line parameter is this
What is
voltage.
P1 and P2?
It's a node 1 and node 2, or point 1 or point 2.
Yeah, which one? What is that?
That is the place where you need to pick the measurements.
Sorry, your mic isn't that great. Would you mind switching to the laptop microphone? If it in the bottom right corner of your screen. Do you see the microphone icon? Hello?
Can you hear me clearly?
Yeah. Yeah. Yep. Could you switch the microphone to your laptop microphone?
My laptop is away, so I'm using a headphone.
Sorry, what? You're using the phone as hello? Hello?
Hello.
Yeah, yeah. What did you say?
Yeah.
Yeah? Hmm. Hello? What are you doing right now? Sorry.
1 minute.
What are you doing? Would you mind telling me what you're doing right now? What?
Can you hear me now?
Yes. We can continue, right?
Yeah, yeah.
So what is P1 and P2, may I ask?
It's a point of measurement before the transmission line and after the transmission line.
So it's just a point.
Point of measurement.
Point of measurement. Got it.
Yeah. So first, they have given a value of 100 kilovolt, 50 hertz, and the transmission line parameters given, and the load values are given: 100 kilowatt and 60 kilowatt. So first,
Right.
we need to start with the three-phase source. So if you double click on the value, we can enter the value here. So we already know the value is 10 kilovolt, 50 hertz. So I'm going to give
Mhm.
10
Could you
kilovolt.
reshare your screen, please? It's paused for now. Yep, I see it now.
Did you listen this? How we took this block?
Yep.
So once we open this untitled window, double click, three-phase source. In this, double click and give a value of 10K and 50 hertz. And the internal resistance are not there here. They have not given any. So we are disabling that, giving apply. And now we can have a three-phase measurement.
Sorry, there was no what? What?
Am I audible to you or how?
Yeah, so
Or
there's no internal. Is that what you said?
no, no. Am I audible to you? Whatever I'm
Yeah,
speaking.
yeah, yeah. Yeah, I just didn't hear it. You said there's no internal.
Yeah, there is no internal resistance or
Okay.
impedance given. So we are
Okay.
removing that internal. And the P1 you asked, right? So that's the point of measurement where I'm going to use three-phase measurement, meaning measurement. So this is going to be P1. And now we need a three-phase RLC block, RLC series batch. So here we need to enter the RL parameters. The values given are 0.01 ohm and 0.01 reactance. So first I'm entering 0.01 ohm. We need to provide an inductance, so we know the formula. XL is equal to 2 pi F L. So I need an inductance from this. I have reactance. So L is equal to XL 2 pi
Mm.
F.
But
So
why do
that
we
is,
need the inductance?
in this we need to give inductance only. There is no reactance given. 1 divided by 5 fs 50. Calculate. So we get 3.18.
Can I see your equation again? Okay.
This is the value we'll get. So this can be rewritten like 31.8 microhenry. So this value we need to place
Sorry,
it.
the 0.01 is from the J component of Z, right?
Yeah.
Okay.
So it's E minus 6 means micro here. Give apply, give OK. Connect this. Now I'm going to connect the P2. And they given a load, which is RLC 3-phase series RLC load. So here we know the value 10K, 50 hertz, and the value given for the load is 100 kilowatt, 60 kilowatt. So I'm putting 100 kilowatt. E to the 3, E3 is nothing but 10 to the power 3, and negative var is 0, and inductive var is 60 E3. So now all the values are given. Now we can have power GUI block. So this block is the header file to run this entire program, what we did as a simulation. Just connect scopes to visualize the graph.
Hmm. Could I see the load again?
Yeah.
Yeah.
I need two outputs from this. So I'm selecting two.
How
So
did you
then
do
I'll
that? Sorry.
double click on settings, number of input ports to two, click on layout and select how you need, whether left right pattern or top down pattern. I'm
Oh,
selecting top down pattern. Click OK. Then you'll get two outputs. Same thing I'm connecting here also. This is just right click and hold, you'll get a copy.
right click and hold.
So now if you run this will run for 10 seconds as it is a default value. And you can double click this to see the results. This is the input voltage and current. This is the output voltage and current. So you can zoom and see that yellow is having a phase shift because of the inductive values and the inductive mode. You can see the voltage is leading. Sorry, the current, yeah, current is lagging, voltage is leading. So voltage starts in the 0, current starts after certain time here. So this is the phase shift what we get, and this is the graph we achieve. So we can give a name here, like click on settings, go to time, click show time in all the labels. So you can see now the time appears in the x-axis.
Sorry, could you do that again? Sorry, that was quite fast. You went to time and
Time,
then
click this, click all,
okay, okay.
and click display. In this, you can give the top one is voltage in V, the bottom one is current. So you'll get the XY labels.
Oh, you know that we need to plot the things in the workspace, right? Not on Simulink.
If that is the case, you can give a value, log it as a array,
Mhm.
give a value, name as out, so that all the values will be stored in the out variable. And we need a time also. So click clock and send that to workspace.
What is the clock for?
We need a time axis. This will give an amplitude. This will give a time. This also I'm taking it in array. Time. Name is time. So now we have pushed the time to workspace and this voltage and current signal to workspace. The variable name out.
Why do you have to do them separately? Why can't you just take the time from this graph?
That will be, if you are taking it from here, it will be complex. You can use this. I'll show you another way. You don't want this thing. If you're taking it from here, then you need to select structure with time
Mhm.
and then you need to run. So once you run, you can find the out variable as a structure here. Double click that. You can see the signal separate. So this is A phase, B phase, C phase. So the amplitude values are out dot signals of one dot values, and time signal is known as out dot time. So I'm going to plot only the first phase. Go to command window, plot, give the name, same like whatever is shown here, out dot signals dot values. So I need this in the y-axis and I need an x-axis of out dot time. You give enter, you can see that it's not. This is how we plot from the workspace. And if you want to plot B phase, C phase on top of this, sorry, current values also on top of this, then you can see in the signals, the next, which is signals of 2. So this is figure number 1. You can pick the figure number 2 and plot same with second signal. And you can see figure 1 is a voltage, figure 2 is current. So here also you can insert X label, time, seconds. Y label, current, enhance, insert Y label time, 10 seconds, Y label, voltage,
Are these graphs not from Simulink? Are they from Simulink?
yeah.
Like these graphs
This is
in
from
Sim
the workspace. This is the workspace. From here, I have double clicked and opened this and I'm plotting it here. Same graph what you seen in the Simulink, you can see it from here also. All the graphs are same.
maybe we do it in a live script. That has to be submitted in a live script.
That is the case, then I can use saving this file as question part B, question B1. And you can use this command sim save this live script.
What?
So first it will simulate and then it will open the figure one and it will plot the first and then second. So the file has to be in the current folder. So my folder is of the downloads. I'll put it in the MATLAB folder. I'll copy this. So I'll save this in the MATLAB folder. You can see my MLX and SLX both are in the same folder.
Right. I think the whole thing should just be done in the live editor. Yeah.
You can see here.
Yeah, that means the scale needs to be fixed as well. So
And so it is going to open as separate figures. So if we want we can save this. Down 1 second. And label also. Label. Label. CD. Current. Fine.
Yep.
Hello.
Uh-huh. Yeah. Sorry. Um,
This current graph and then this graph. That is what we are plotting.
so yeah, what is the answer to QB1 then? What can I see the calculation then?
If you want to see the calculation, you can
Or for I, 'cause that's what
I2.
it's at.
I2, right?
It's at, yeah, I2.
I'm changing the solver.
I think we have to calculate it ourselves and show work, like use MATLAB to calculate it and show it in the live script.
Yeah, I was asked to show you the Simulink part. The calculations I'll be providing you as a report.
But the Simulink has to like it has to be in the live script form. That is the only way it can be submitted.
Yeah. Like here in the Simulink, whatever the work they asked is the same thing, whatever I'm showing here. This is the live script, and this is how we can going to submit it. So you need both the files.
Right, I understand. But this doesn't calculate I2, right?
Yeah, I2 you need to calculate in different way. That is what I'm going to do. If you want to show the I2, so now I2 amplitude. I2 angle. Show it like this. So, This is amplitude. And
It's AN.
yeah, this is amplitude and this is angle. And we want to show that in the TypeScript. This is the value of amplitude and this is the value of current. So the angle is radian value. So convert that to degree. Angle in degree.
What's I2A and I2AN?
I to A is the amplitude, I to AN is the angle.
Is a what? Angle?
That will be a complex value, right? Of current.
Yeah.
Amplitude and angle will be there for it.
Sorry, amplitude and what? I can't hear.
Amplitude in amps.
Amps. Wait, I2AN is amplitude.
I to AN is the angle, A is the amplitude. Or I'll name it like this.
Okay.
I to
Okay.
amplitude, I to angle. Confusion.
Yep.
Can you go to the next question?
Yeah, let's do it.
So they asked us to replace in the Simulink the line parameters so that the new line impedance is 1 ohm and J1, not the new phase current and new phase voltage. Explain the difference in this. So you remember this value. Amplitude is 9.5.
Wait, everything is done in a live script though.
Yeah.
Okay.
Now, this question B3. So what we have to do is, this is going to be 1 ohm, and this inductance we need to recalculate again. So instead of 0.01, we need to apply 1 here. So around 3.2 milli Henry. So I'm changing that to 3.2 milli Henry. Save it and run the script. The script name also will change to, and here also I need to change the names. So previous value of current was 9.52 something. Presently 9.5067 something. That is the difference. And angle change also you can see. And this is because of the line parameter change.
Could you write that down, please?
Yeah, I'll be preparing a report for this. So you can get it by tomorrow.
Oh, okay. So you
Just
will write.
for the MATLAB explanation, I'm explaining all this.
Okay. So right now you're just doing the explanation and
Yeah, just your
what?
I'm just helping you to understand the simulations. So I'll give all the description like why, how the difference is happening in the report. Shall we jump to the next question?
Could you please explain again why it's different?
Yeah, we have entered different value of resistance and reactance. So this resistance and reactance is going to act as a load for the source. So before it was 0.01, now it is 1. So there is a difference in resistance in the transmission line. So the current through P2 also will change accordingly.
Oh, okay.
So there is more resistance here. So there is a change in resistance, change in current. So there's a drop of 0.02 something because there is a increase in resistance from 0.01 to 1. That is the reason. If the resistance, series resistance increases, the current should drop. So it is increasing here and there is a drop in the
Right.
current.
And for B2, what is the difference between the currents?
Where?
For B2, was B2 answered?
Yeah. B2 answer is this 9.5218
Yeah.
and
And what was
B3
the
is
explanation for that?
pardon?
And is the explanation for that because it's, wait, yeah, what is the explanation for that? What?
We need to calculate and compare. So in the calculation also we should get the same and here also we'll be getting the same. There will be a calculation which will be given in the report. How we calculate
Why is
that.
it different? As in,
Pardon?
why is it different
Yeah,
for
the
B?
resistance is increasing, so the current is dropping.
But
That is
in
the reason.
B2, in B2, it doesn't ask you to increase the resistance.
Yeah, there is only 0.01 resistance. Here it is 1. If you
Oh,
increase the resistance, the drop in current will happen. That is the
no,
explanation
but
for that actually.
B2 doesn't tell you to, question B2 doesn't tell you to increase the resistance.
Yeah, so you are getting this.
Right,
You already have a resistance of 0.01, but
right.
in B3, they asked you to increase the resistance, so you are getting this.
Yeah, I understand that, but like I'm talking about B2 now. Um, going back to B2, it says explain any discrepancies between the current graph and the results obtained in question B1.
You need to, the question B2 is just to plot the current graph and voltage graph.
Right.
If there is any discrepancies between the current graph and the results obtained in the QB, B1. B1 means you'll be having a calculation. There is no any other simulations here. So in this
Yeah.
you'll be getting one I2. That I2 with the simulation, whatever you're getting the I2, if both are same or difference. If there is a difference and why it is a difference. In that way we need to explain. No discussion is required about the phase angle, only the amplitude they asked. Calculated value and simulated value, if you have any discrepancies, why it is happening. That is what they ask.
Yeah. So what is the answer?
We need to calculate and we need to compare. If there is no discrepancies, I'll be giving no changes. Both are same. If there is a difference, then I'll be identifying why it is different and I'll be answering that.
So you can't answer now then.
No, now I can't calculate. I don't have paper or pen. Just I came here to explain you the simulation part. That is what asked from me to for today.
I mean, are you gonna
Just I'll be
complete the
giving you as a
report?
report tomorrow.
Okay. But in the report you're gonna give me, is it gonna be completed or?
Yeah, that I'll be giving you.
Okay, as long as it's done in the report then. Okay, we can move on then.
Before they have another circuit where they have a transformer, transmission line, and another transformer. Then I'm taking another one. Untitled Simulink. So they given VPA primary of transformer A, secondary of the transformer A, connection is star to ground and delta, and transformer B is delta to ground, and the load and the source voltage are going to be same because 1 kilovolt. So the 1 kilovolt I'll be using in the source because that is the primary. The secondary it is 13 kilovolt. So the transformer to 13 and then here it is 1 kilo. So the load also will have 1 kilovolt. So as it is a modified system, from there we are going to modify it. We can modify it from there itself. So this I'm going to name as B4. I have P1, P3, P4, P2. Just pulling this far away. I have P1 here, P2 here. I need P3, P4. So P3, P4, and the transformer. So here we can use combining transformer. And they given it clearly that the transformer A is star G delta 1. So the secondary is going to be delta 1. Parameter is going to be 50 hertz. And this is going to be, primary is going to be 1K of voltage. The secondary is 13K. Yeah, 13K. Using the same transmission line. Here it is going to be reversed. This is going to be delta. This is going to be star G. And this is going to be 13. And this is going to be 1K. Here primary is 13, secondary is 1K. And here the voltage is going to be 1K. Rest all are same. Build the model, keep all the other parameters same, and question B3 provide. So they asked to keep according to B3. So B3 means then we use so now they asked Provide the three-phase voltage waveform for the current I2 new and the voltage at point P2. Voltage and current at this point they asked. Explain difference between the simulation results obtained here and the results obtained in question B3. So here I've connected the scope here. I'm using face-to-face measurement. Delta will not have the ground, so face to ground will not work here. That is the error I got. I'm changing it to face to face. This is going to be the new graph. Current voltage. I want to put that in save as B4. As B4. I'm just copying this and pasting it here. And saving this as this one, which is a phasor simulation. So this is the amplitude and this is the angle. So here the increase in current happened. This is because the voltage, whatever we had before was 10K, now it is 1K. That is the reason. You can see the primary and the secondary are 1K. So that is the difference we'll be getting. That is what we'll be explaining. Required to size a capacitor to connect in parallel to the load. The aim of obtaining the unity power factor at 0.2. So 0.2 power factor, if you want to see, there is a difference in angle of around 30 degree. So we need to add a capacitor. Instead of the inductance, I put capacitance. So angle is 0, that means it is unity power factor. It's close to 0. That is what they expected here. Both calculation I'll give you in the report. No simulations are required in that case to check the model.
Yeah. Oh, it's still, yeah.
And here, we will see.
And
Yeah, this is the answer.
So
Yeah.
you know that the report has to be in live script, right? Just to tell you again.
Yeah. This is in live script.
Yeah, I'm just letting you know when you send me the report, it has to be in live
Yeah,
script.
yeah. These screenshots only I'm using. And I'll be giving you this entire files as a folder. Just you need to run this live script to get this.
Yeah, great.
First one, B3 and B4. All the three
So
are in live scripts.
yeah.
So with them tomorrow, the same time, you'll be receiving this report.
Okay.
That is what I committed with them.
All right then. Let me just see if there's anything to ask. What is a unity power factor, by the way?
The power factor is like voltage and current should be in line with each other.
So in
For
phase.
example, n phase. For example, if you see this, I'll take this here. Next, plot for only one phase so that it will be clear. I'm taking a one phase, A phase from voltage and A phase from current. And I'm going to merge this plot. So as the voltage is higher value, so I'll add a gain.
Are you showing me the power factor right now?
Yeah. So you can see the blue one, yellow one is the voltage and blue one is the current. So there is a clear lag in the starting point
Uh-huh.
of the voltage and current that shows the power factor is not correct. It's not unity. So to make this unity, you can add a capacitor of close to the inductive value. You know, merged. Are you seeing it? Hello.
Um, Could you show me the capacitor?
I'm removing the capacitor. I'll be getting this result. You can see this is the 0 point.
Right.
There is a clear lag
Yeah.
if I'm connecting it.
Can I see the values on the capacitor?
Same value as the inductor.
So just same value as what? Sorry?
Inductor value. Inductor value 60 is the load
Right.
of
It's just
inductor, right? Same.
it's to cancel out the impedance, right?
Yeah. Due to that, we'll be getting the unity buffer. That
Okay.
is what is happening. So it will start from 0 exactly. So you get unity power factor. That is called unity power factor.
Wait, so why do you need to calculate the theoretical value? Isn't it just 60?
That is a tricky question. Like how you do way of checking.
Yeah, why do you need to calculate though? Because don't we already know it's 60?
That is a calculation. If you do it in hand, you need to calculate the impedance and then you need to recalculate according to the. There is a formula for Q equal to P tan phi, and you need to put that phi value in the tan. Then you need to get a P value. Accordingly, you will be calculating Q. So P is now already known 100 K. Q is unknown or negative. So in that way, you need to calculate and show that's it. That is what they expect.
Okay.
There are some formulas you need to implement and show. As it is in simulation, I'm showing you directly. But when you show it calculative way, you have some equations to be written. So that there. Anything else?
Um, but how is that? Okay, and then for B, back to B, yeah. No more questions.
Okay, then I'll share you the report tomorrow. I'll share it to him. You can correct. So if you have any questions, you can ask him. He will be sending me as a message. I'll share you as a.
Yeah, I will. Thank you.
Thank you.